Hello everyone. Today we're looking at function machines, and we're going to touch on a little bit of algebra today, just some of the sort of first basics of algebra. So can you write today's date? This is the date I'm expecting you to do it. If you're doing a different day, not a problem, but today's date please. There's the learning objective. We'll be needing to look at pages 92, 93 and possibly even 94 of the textbook. So short date please, learning objective, pause the video while you're doing that, and then we'll start the lesson. Right, okay, so we're going to start off with a function machine. So really all a function machine is, and you can draw a function machine kind of however you want to, but as you'll notice in your books, they tend to be looking a little bit like this, where it's just like a sort of pretend machine, okay, and then in here we have the function that is occurring. So that's the important bit in the middle there, and sometimes people put on different colored lights and things like that, don't they? If you want, you can put a little antennae, okay, yeah, or wherever you want. So all a function machine is really is that a number goes into the function machine. So say for example, if I wanted 4 to go into the function machine, okay, I'm putting 4 into the function machine there, okay, and then the function machine will process that number and come out, for example, then it could come out with 20, okay. So 4 goes into the machine, 20 comes out to the machine. So you're working out what the machine is doing to the 4 to get to the 20. Now in this case you've got two choices, okay, so it would be 4 and then something is happening to that 4 equals 20, okay. So you could have, you've got two choices here. See if we can just work those out in your head quickly. 4 something 20, 4 something 20. So it could be 4 times 20. So 4 times 5 is 20. Or it could be 4 add 16 is 20. Now both of those are feasible answers, okay? Both those are feasible answers in there. And usually there's more than one number going in. So that'll show us how we work that out. I'll show you that one in a moment. But all a function machine is a number goes in, then a number comes out the other side. Now the ones we'll be doing today, there will be more than one function machine, so it'll just go to 2 function machines. So say for example we've got this one here, then the function machine, now first, so we've got this here, okay, and we'll still do the dots and stuff, still do the dots and up. And then here you might have 23. So we can see that going from the 20 to 23, all that can be is plus 3. So I've done that one a little bit small. So that'll be plus 3. But we're still not entirely sure what this one is yet. Okay. So if we've got another number going in there, so say for example we've got 10 going in here. Okay. If we've got 10 going in, and then this number is 50, and then this number here will be 40. Will be 53. Okay, now we can see, is this going to be, is our function machine going to be 10 plus 16 equals 50, or is it going to be 10 and it goes into the function machine times 5 is 50? So we can see now from both of these, yeah, we can see that from both of these it's obviously going to have to be the times 5. 4 times 5 is 20, yeah, 10 times 5 is 50, okay, so we know that this is the times 5. So that's our function machine there basically. So we might have another number going in, so we could have 7 going in. 7 times 5 coming out then is 35. Then going into the next one, we're adding 3, 38. Okay, so all a function machine is, it's basically it's just working out sort of a sum going along. Okay, a sum going along. So we'll do one more quick example, okay, before we go have a little look at the work we're doing today. So let's have a little look. So we've got our function machine. Shouldn't have. Okay. Function machine there, and going into it we've got 3, we've got 10, and we've got 5. Okay, I won't bother with the lights because I want to get this part done, and in here's the function that's going to happen with it. Then we've got 15 here. Okay, then we've got another function machine coming up the other side. Okay, function machine there. And on this side we've got 13, 48, and 23. So again, we can work out what the function machine is doing. 3 through the function machine to 15. So that could be our possibilities. We could be adding 12 to get to there to there, adding 12, or multiplying by 5. Now we won't know until we look at the next number. So on this one, if it's 10 add 12, that would make 27. So, sorry, from the 15 to the 13, we can see there has to be a minus 2. So is it 10 plus 12 is 22. 22 take away 2 is not 48. Or is it 10 times 5, which is 50. 50 take away 2 is 48. So we can see straight away that this has to be multiplying by 5. Yeah, because 10 times 5 is 50. 50 take away 2 is 48. So we can do this one then. Let's just check if this is correct. 5 times 5 is 25. 25 take away 2 is 23. So we can work out the missing numbers in our function machine, and from there calculate the answers. Now that is basically what we're going to be doing. If you have a little look, let me just get the book. We'll have a little look at the question 1. Hang on, I'll put that down. Question 1 today, okay, in the book. So again, we've got 10, something's happening to the 10 to make it 20, and then let's go into 21. So we can see going from 20 to 21, this has to be plus 1. This has to be plus 1. So this can be either adding 10 or multiplying by 2. So let's look at our next one below. So it's 30, something's happening to the 30, then it's adding 1 and becoming 61. So let's have a look. It has to be, so it has to be 10 times 10, so it has to be 30 times 2 is 60. And then add the 1. So when you're doing this work in your book, you would draw the functions, okay? You would draw the function machines. So if you were doing this in your book, yeah, you would do the 10, you do the 30, you'll do the 100, you'll do the 50, and you'll do the 200, like that, okay? And you can work out from these that your function machine, okay, your function machine will be, okay, and you can draw the little colors and the lights if you want, okay? So we can see our function machine, because we've got 20 here, and we've worked out that that's going to be times by 2, because it can't be 30 plus 10 is 40. So it has to be multiplication on this one, okay? Times 2, so we know this is going to be 60, and then we've got on the other side of the function machine, we've got that, just put it in, okay, excuse the terrible drawing of a function machine. And you can see here we're adding 1. So the function machine here, we're multiplying by 2, adding 1. So this becomes 61, this becomes 21, like that. Oop. Yeah, 61, 21. So it's fallen off the edge of the page a bit. Okay, and so on. Okay, have a go, please. Don't worry about question 1. Have a go at question 2. Okay, have a go at question 2 and question 3. So when you come to do it, please draw them. Draw your function machine in. You need to work out what goes inside your function machine, and then the only set of numbers you need to fill in are the middle ones. I think there might be an end one missing here as well, because these n numbers here are given to you anyway, aren't they? These numbers are given to you anyway, aren't they? So it's not quite fitting in. Right, so page 192, please. So it'll be page 192. Page 192. Just do questions 2 and 3, please. Questions 2 and 3 on page 192. Drawing them out properly. Pause the video while you're doing that, please, and then we will carry on with the rest of the lesson after that. Okay, so pause the video and have a go at the questions on the board there. Okay, thanks. Right, well done. Hopefully that's all done for you. That's all done. Right, so actually, could you mark these yourselves right now? Okay, if you can mark these yourselves right now, that would be great. Yeah, there we have them. Make sure, please, you get the right number in, and yeah, all the numbers are correct. Give them a quick tick. Pause the video while you just mark those, okay? Now, what I want us to look at next is a little bit of algebra. Now, we're going to come back to these questions in a moment, but we're going to look at some how algebra works. So, say for example, in algebra, when you're multiplying. So if I'm multiplying, now algebra is kind of weird. I don't know the value of a number before I start with. So a number times 10 equals 30. So any number times 10 equals 30. Now I can work out what that number is, can't I? I can work out what that number is. It's a bit like a question mark. So if I give you this with that, times 10 equals 30, what goes into here? And the answer is 3, isn't it? 3. So algebra, the algebra we're going to be doing today anyway, it's just where we don't know the value of a number. Where we don't know the value of a number. Okay. Right. So now when we come to writing an algebraic expression, okay, we wouldn't write it like this, okay? We would write always put the number first, okay? So it would be 10 times n equals 30. So we would swap it around like that first of all. And actually in algebra you never see a times sign. It's an invisible times sign. So 10n equals 30 would be how you express it, because between the number and the letter there is an invisible times sign. So that is 10 times n equals 30. So in algebra you never see a times sign, believe it or not. Okay. So 30n equals 10n equals 30 is how you would write it. So have a go, please, at writing. So if I've got n times 4 equals 20. Very quickly, what's the value of n? Yep, good, it's 5. It's 5. Now, if I want to write this expression out properly, okay, I'm not going to call it n times 4. What am I going to put first of all? I'm going to put the number, okay? And then after that, I'm going to put the letter, okay, n, and I'm not going to put a times sign between them, okay, because 4n is always the same as 4 times n, okay, the invisible times sign in algebra, okay. N is just our missing number. N is our missing number, is equal to 20, okay. So from there we can work at the value of n, okay. Right, one more. Let's go for, so if I wanted to write, say I wanted to have a number, and I've got a number n, and I want to times that by 5, and then I want to take away 3 from that. Okay, this is how I would write the expression. N times 5 is the bit I'm going to focus on first. Okay, Now I'm going to put the number first, 5. I don't need my times sign, so that becomes n times 5 is just the same as 5n. I'm going to take away 3, and that is my expression. Okay, that's my algebraic expression, 5n take away 3. Okay, 5n take 3. Now there is a point to this, because the next questions we're going to be writing our own algebraic expressions. Okay, so let's go back to our answers here. Our answers. Now, for the next set of questions, you will be asked, let me just get the book, you will be asked to write an algebraic expression for a function machine. Now, if we have a look at this, we've got our number here, our number. Okay, so we start off with a number. Okay, so we're going to call this n. Right, so this is our n, and what's happening to our n? It's been times by 10. Okay, and then the answer to that, and we don't need to put the answer there because we know that n times 10 will give us an answer. Then from that, we're going to take away 1. So that is our algebraic expression for this. Okay, n times 10 take away 1. Remember, that's not how we're going to write our algebraic expression though. We know that n times 10, we put the number first. We don't need the times sign, so it'll be 10n minus 1. That is the expression, the algebraic expression for this function machine. Okay, 10n, the number, times by 10. Okay, take away 1. Have a little work out for yourself, just a second, what the algebraic expression will be for question number 3. Question number 3 here. Yeah, so we've got our number, then we're doing that to it, and then we're doing that to it. So it's our number, doing that to it, then that to it. Write that down in your books, please. Okay, write that down in your books, and then we'll go over it. So remember, this is the number we're starting with. This is the number we're starting with. So we're starting with an n. Then what are we doing to that n? A number. N just means the number. We're timesing that by 3. And then what are we doing to the answer? Adding 2. Okay. So that's what we're doing. It's the number multiplied by 3, add 2. Now how we're going to write that is, we're going to write that, of course, we put the number first, so it would be 3n plus 2. And that is the algebraic expression for that function machine. Okay, algebraic expression for that function machine. Have a go at, I only want you to do questions 1, 2, and 3. Okay, because we know how function machines work. So on page 93, just have a go, please, at questions 1, 2, and 3. Questions 1, 2, and 3. And you'll see, for example, just have a go. Okay, you have to see which of those expressions relate to the function machines below. Okay, which of those expressions? So we've got the expressions, this expression, which of those does it relate to? This expression, which of those does it relate to? Okay, have a go at those, pause the video, and then we'll just do the last part of the lesson. Okay. Right, good. So just to finish off, okay, sometimes with function machines, you can have sort of missing numbers. So let's, for example, let's have a look. If I've got a function machine which is 4, and then my function, I'll just do a very basic function machine, is times 10, which will give me 40. And then my next function is plus 2, which will give me 42. Now, there might be a question whereby I don't know what this first number is, I don't know what this second number is, and the third number is 502. Now, can I work out these other numbers? Okay, these other numbers. Now, the trick with this, okay, and I'm just going to do this briefly because this is just an extension question if you want to have a go at it. Now, when I'm working in this direction, okay, I have to times, I have to add. But when I'm working backwards, I do the opposite. When I work backwards through a sum, I do the opposite. So if I'm working this way, for the 502, instead of adding 2, I'm going to do the opposite of adding, which is taking away. So this time I'm going to take away 2. So that gives me to 500 there. Now, again, to go from this here to here, when I'm going the wrong way of the direction in the sum, instead of timesing by 10, I do the opposite of timesing, and I divide it by 10. Okay, divided by 10. So this becomes 500 divided by 10 is 50. So I can work out this missing number. Now this is it's worth trying to remember that, because when you go backwards in the sum, you do the opposite operations. So anyone who fancies having a go at these, just have a go please on page 94. This is an extension, so you do not have to do it. Okay, extension, page 94 extension, and have a go at just question 1 please. Just have a, in fact, we've kind of done question 1, so have a go at question 2, and we'll maybe have a look at that next lesson anyway. All right, good luck with that. Okay, cheers, bye-bye.